Hi, Ghosts and Goblins. Mr. Drew here again with you, and welcome back for another science lesson. Today, it is soon to be Halloween, and my costume was Schoology. However, I was unavailable. Anyway, that could be why my camera may or may not be working now. So if you can't see me, that could explain quite a bit. Hey, did you ever wonder how much candy will kill you? Well, believe it or not, science has the answer. You can find out how many fun-sized candy treats that you might get at Halloween would be potentially lethal by multiplying your weight in pounds by 13, dividing by 9.5. I wonder if I could eat that many treats.
It's estimated that candy sales this Halloween will reach upwards of $2.5 billion in the U.S. And keeping within the bounds of this season's spookiness, today we're looking at how many pieces of Halloween candy, when eaten in one sitting, can kill the average person. It isn't called candy if it isn't absolutely loaded with sugar. The average American consumes around 22 teaspoons of added sugar per day, even though experts suggest that men consume no more than 9 teaspoons, and for women, only 6. Of course, all those added sugars haven't come without a toll. The National Institute of Health found that around 2/3 of Americans are overweight, and while there are varying factors that contribute to this problem, candy is most certainly putting its own dent in it. Table sugar, or sucrose, is a simple carbohydrate that is composed of 2 main parts, glucose and fructose. Just like with high fructose corn syrup, our bodies break
My apologies.
these separate parts. Glucose passes through the liver and is readily distributed about the body as your cells can use it for energy. Fructose, on the other hand, sticks around in the liver, the only hardware in the body that can break it down into simpler pieces. The liver then converts around 50% of the fructose into glucose, almost 30% into lactate, and whatever remains gets stored as fat. When you load your body up with sugar, all that glucose can't be used at once to power your cells, so it ends up being converted and stored in cells called adipocytes, or fat cells. So you can see why all those added sugars end up having an extended stay right here. Candy can come with nuts and other treats inside, but let's focus on sugar for our hypothetical death by gluttony. As the old saying goes, the dose makes the poison. At high enough doses, sugar can be toxic. But how much is too much? We're going to need to take a look at the oral LD50, the quantity per kilogram that can successfully kill half of an animal test population such as rats. The LD50 of sucrose is 29.7 grams per kilogram, or 13.5 grams per pound. The LD50 represents toxicity for things consumed all at once and doesn't guarantee death. It's just what kills 50% of a population. And since these numbers represent toxicity in rats, it's possible that sugar might be more or less toxic in humans. Scientists often use approximations like these because getting the lethal dose of sugar or other compounds in humans would be widely unethical for obvious reasons. But if there's a human testing for the LD50 Nutella, you can sign me right up. The average person in the U.S. weighs around 180 pounds. That means in order to reach the LD50, they would have to eat approximately 2,440 grams of sugar. It's about 5.4 pounds, folks. But what does all this sugar mean in terms of a trick-or-treater's Halloween loot? An average piece of fun-sized Halloween candy packs 9.3 grams of sugar and runs you about 75 calories a pop. So in order to reach the LD50, the average person would need to eat 262 pieces, nearly 20,000 calories worth. So how about in terms of a specific Halloween staple, candy corn? A single piece contains approximately 1.5 grams of sugar, which would put our lethal dose at 1,627 pieces. I could probably do it. So now you know the numbers of the average person, but what about you? Down in the video description, there's a handy...
What about you is right. You want to figure out how many fun-sized pieces of candy it would take? Use this formula. Your weight in pounds times 13 divided by 9.5. I'll pause so you can figure it out. You got it? That's pretty amazing that much candy, which might be possibly something you might be able to do, could be lethal. Scary fun. All right, guys, let's continue on with today's scary fun lesson. Homework this weekend being Halloween is to be fun and safe. We're going to continue on a little bit with our properties of matter. Let's take a look at our note packet. Because if you remember last time, your job was to complete page 2. The list of the properties that we're going to be using for this whole entire unit, and it was up to you to figure out the answers. Hopefully you looked on Schoology, and if you did, you saw the definitions and the word wall or some of your classmates even might have helped you by putting the definition and a picture. Hope you joined in as well. If not, or if you'd like to check your answers, go ahead and pause the video. Fill in your chart. You're going to need it. These are the words to memorize for Unit 2. Solubility means dissolving. You could also say non-soluble, such as sand is non-soluble, whereas salt or sugar is soluble. Ductile is a fun word. If you've ever seen a wire or a coat hanger, you know how they make that? Metals can be stretched or pulled into wires, whereas a branch or a tree could not. It would probably break. Malleable, think of the word mallet. A mallet is a hammer. Remember the old blacksmith hitting the horseshoe, changing the shape by hitting it with a hammer? Well, that's malleable. Pennies are made by squashing copper into a sheet of metal. So, some new words there and some you've already probably heard of before. The rest of our list includes words like luster, the amount of shine. Mirrors are shiny, lumps of coal are not. Hardness is often confused with strength or durability, but we're actually talking about the ability to be scratched. You might have done something like this when you studied rocks or minerals. Some minerals can scratch easily, like chalk, and some cannot, like diamond. Your ability to scratch is the hardness test. You know flammable, and you've probably seen rust on a bike, but what about effervescence? The little tiny bubbles released when things like baking soda and vinegar react. So a reaction causing bubbling. Not so much what you do when you open a can of pop. Those bubbles, although effervescent in common language, wouldn't be effervescence in the chemical way that we're talking about it here. If you need to pause, go ahead and make sure you get in words and definitions that are similar to these. In our packet, last time we looked at things like water, using some of our terms to define or describe water. You also could define and describe oobleck. Now, oobleck's recipe is in your packet, right on the other side of your definitions. And if you have permission and a space and the ingredients, you can make oobleck too. Here's what I would suggest. Get a plastic bag, add some cornstarch, and slowly add small amounts of water. Add it slowly so that you don't overdo it. It doesn't take as much water as you might think. You're looking for oobleck the consistency of like glue, like Elmer's glue, not milk. When you stir the oobleck in the bag, you'll notice if you press hard enough, it's going to feel like a solid. You'll know you've got it right if you seal the bag and tip it upside down and it looks like alien goopy blood dripping down the sides of the walls of the plastic bag. You can add food coloring for that extra spooky effect. Don't try these fun but possibly dangerous activities at home.
Congratulations on the second season of Street Science.
Oh,
What is happening this season?
Oh,
two?
we're going bigger. We're blowing up all kinds of stuff. We're crashing cars, dropping cars, chemistry, all kinds of cool stuff, if you're
blowing
into
up.
that sort of thing.
Oh, yeah, I'm into it. You always bring something cool to do. This is a
Yes.
Halloween-themed,
Right.
some science experiments. What is the first one you got?
It's a spooky time, so spooky stuff.
It's spooky.
So we've got some dry ice.
Yeah.
So this is what we're going to do. We're going to make some bubbles, but we're going to make bubbles filled with dry ice. Now, dry ice is just solid carbon dioxide gas, right?
Uh-huh.
So I'm going to drop it in, and you're going to see.
Yeah-huh? I'm not so sure that yeah-huh means that he really knows what this means. Let's talk this through quickly. Do you see the bubbles there? The bubbles are being released when dry ice, in other words, solid carbon dioxide, which is colder than regular ice because carbon dioxide isn't water. Carbon dioxide freezes at a lower temperature. See the bubbles coming up? That's carbon dioxide gas.
A little bit of CO2 and some water. So, There you
So
go.
it says
So you-
carbon dioxide and water,
and water
vapor.
vapor. Yeah, there you go. So once it sublimates, which is transferring from a solid
I
to
know
a
what
gas.
sublimates
I know you know. I'm just telling for the benefit of our friends in
I
TV
know,
land.
yeah,
Right,
of
yeah,
course.
right.
Please.
Okay.
I missed your supplement.
Right. So now this is what we're gonna do. You got your glove on? Okay,
Yes.
great. So I'm gonna just put this over here, and I've
cool.
got my vapor coming out here. Now I'm just gonna dip this in, and we get. There you go. There you go. So carbon dioxide's heavier than air, so the bubbles don't really float; they just kind of flop.
So many cool properties that he just mentioned there, and how the changing from a gas to a solid, and words like sublimates, definitely things we're going to learn this unit. Now there's more. If you want to see more about sublimation and pumpkins and all kinds of fun things, go ahead and check out my video links, and you can see the rest of this video. Play it safe though, guys. Oobleck's good. Pumpkin sublimation, probably not so safe. So thanks so much for joining. Want you to have a happy, safe Halloween, and calculate that number, okay? Because we don't want you to go over the number of fun-sized candy bars that could be lethal. All right. Thanks for trying science. See you next time.